An example of taking a vector that's written as a magnitude and a direction and changing it back into regular IJ notation. In this case, though, it's kind of worded a little weird. We have a force of 150 pounds being applied to an object 20 degrees west of north. Well, the first thing I want to do is find out which way it's going, and then just, call the magnitude of this thing 150. 20 degrees west of north, well, north is going this way, west is going off to the left. So if you're 20 degrees west of north, you're kind of leaning into that direction. So our vector looks something like that. And what we know about this vector is we know that the magnitude of it, let's call it V, is 150 pounds. So we'll just call the magnitude of V 150. And we know that this angle here, coming off of the y-axis, is 20 degrees, so the angle of opening must be 90 plus 20, which is 110 degrees. So we can set this up as the magnitude of V times a cosine of theta I, cosine theta or sine theta j, and then see what comes out of it. So our angle V, or our vector V, is equal to the magnitude of the vector times cosine of theta I plus sine of theta j. And then just plug in what we know. So V is going to equal 150 times the cosine of 110 I plus sine of 110 j. And if we calculate this out, I would distribute the 150 and figure out what 150 cosine 110 is and 150 sine 110 is, and then just write their approximate answers in. And what we get is a negative 51.3 I plus 141.0 j after a little bit of rounding. And that kind of corresponds to where we are, 51 this way and 140 up that way. And that would be the vector with a force of 150 pounds being applied to a 20 degree west of north direction.